Hi everybody, welcome to our first video from Unit 5. And in this unit we're going to be talking about naming compounds, formula writing, and balancing equations. And so the first part of this we'll talk about naming compounds. And of course you probably want to know, well, how do we name compounds? And the answer is it depends. It depends on what type of compound you have. So what I'd like you to do first is just take out a sheet of paper. We're just going to get a couple things down, and then we'll go to our packet and do a little bit of practice with that. Okay? So you should have a sheet of paper out, and on your sheet of paper I want you to write down, how do we name compounds? And then we'll answer that. The answer is, it depends. On the type of compound you have. Because there are different rules for naming for different types of compounds. So the first type of compound we're going to talk about is a binary compound. Binary compounds are compounds that contain only two elements. How would you know if you had a binary compound versus a non-binary compound? Obviously, non-binary compounds contain more than two elements. That's really the difference between them. But how can you tell by looking at their formula if they're binary or not? The way you can tell you have only two elements is because you will have only two capital letters in the formula. So for today, we're going to focus on naming only binaries, so we'll kind of start there. But if you do have a non-binary compound, there's a different set of rules for how to name them. So we're going to focus on elements that have only two capital letters in their formula. For example, NaCl is a binary compound. However, NaC2H3O2 is not binary. And so we won't be naming anything as complicated as NaC2H3O2 just yet, but we will learn how to name something like NaCl. So the first question, if I give you a formula, you want to ask yourself is it binary? And if it is, then you're going to follow this set of rules. Now, the second question you want to ask yourself is there's really two different types of binary compounds. There is a metal bonded to a nonmetal, and then there are two nonmetal compounds. Nonmetal bonded to a nonmetal. Remember, metals are found to the left of the stairs. Nonmetals are found to the right of the stairs. Semi-metals are named according to nonmetal rules. Okay? So the next question you want to ask yourself is, does my compound have a metal? And if it does, there are a set of rules to name metals. And if it doesn't, then there's a set of rules to name two nonmetals. There's different rules depending on, again, what type of binary compound you have. So when it comes to naming, the way you name not only depends on if you're binary or not, but what the binary compound is made out of. If the binary compound is made out of a metal and nonmetal, then what you will do is you will name the metal. Then you will look up the number of oxidation states. You'll look up the metal on the periodic table. If it has more than one oxidation state, or charge in the box, fancy way to say that, You put parentheses after its name. And we'll come back to that as to what goes inside those parentheses. If it doesn't, you don't need the parentheses, okay? So you would just name the metal. Then you'll name the nonmetal, drop the ending, and add IDE, okay? So you'll look up your metal on your periodic table. If there's only one charge in the box, and I'll show you what I mean in just a moment, you'll put parentheses after its name. Then you'll name the nonmetal, drop the ending, and add IDE. Now, if it does have parentheses, you must calculate. So if you added parentheses, you must calculate the charge on the metal. And there's two pieces of information you need to do that. The way you calculate the charge on the metal is that you use the nonmetal charge, and then you'll pick the negative one. If there's more than one for your nonmetal, you'll pick the negative one. And you must remember that all compounds are neutral. So what that means is that the sum of all the charges on all the ions in the compound must equal 0. And again, I will walk you through a couple of examples of this. Okay? So you'll need to calculate the charge on the metal and then put it into those Roman numerals. Into those parentheses, sorry. So you'll calculate the charge the metal has in the compound. You'll put it in the parentheses in Roman numerals. So, taking you back to, say, 4th grade when you learned your Roman numerals, if it's a 1, then it's an I. If it's a 2, then it's I. If it's a 3, I. If it's a 4, IV. If it's a 5, it's V. If it's a 6, it's VI. If it's a 7, it's VII. If it's an 8, it's VIII. And if it's a 9, it's IX. And if it's a 10, it's X. You will have to memorize these, but in reality, you probably will not have anybody that has a charge greater than 7. That's my bet, okay? So I'll walk you through a couple of examples of this, and then we'll try some also tomorrow in class. On the second page of your notes, you have something that looks like this, okay? You want to first recognize that there's only one capital letter in each of these, and then second, we're only going to name the ones first that we know how to name, the metals bonded to a nonmetal. So we want to scan the list and find a metal bonded to a nonmetal. Remember, hydrogen's considered a nonmetal. So remember, we name our metal aluminum. Then we go to the reference tables and we look up the charge, or in the box, how many charges aluminum has in the reference tables. I hate that these are sideways. So you go here to aluminum, and you can see that there's only one charge in aluminum's box. Bye, guys. So aluminum is +3, which means that's all aluminum can be, is +3. So we do not, since there is only one charge in the box, we do not need to add parentheses after its name. If you actually did add parentheses, you'd be marked wrong. So since aluminum is only +3, right, that's its only possible charge, you don't need any parentheses. Then you name your nonmetal, hydrogen, You drop the ending, usually go 2 vowels in. 1, 2 from the right side, drop that ending, and add the letters I-D-E. This is aluminum hydride. Aluminum hydride is the name of this compound. Okay? That's it. That's all you do. Let's walk through another example. Here in number 2, we have a metal bonded to a non-metal. We name our metal iron. We go to the box for iron and look up how many charges it has. So let's go here to iron and see how many charges iron has in its box. I'm almost done, guys. Right here, iron has 2 charges. Iron can really either be +2 or +3. It has 2 possible charges. So when it has 2 possible charges, you need parentheses after its name. Then you name your nonmetal. Drop the ending, go 2 vowels in. Y counts as a vowel, and add I-D-E. Iron something oxide. Now, what we're going to put in those parentheses will either be a Roman numeral 2 or 3. We have to figure it out. To figure it out, look up the charge on your nonmetal. So if we go here and look up oxygen's charge, it's -2. So oxygen's -2, and there's 1 oxygen. There's 1 iron. All compounds are neutral, so in order to make the total charges equal 0, iron will have to be +2. So we put this charge inside those parentheses in Roman numerals. Iron, Roman numeral 2, oxide. We'll try more in class practice tomorrow. Have a great night, everybody. Bye-bye.